Okay, let's look at this question here. The number x is expressed as this form here, where y and z are prime numbers larger than 3. So essentially, this is a key piece here, because what we need to know is that whether this is already the prime factorized form. Okay, so prime factorized form, basically just understand that prime numbers are like atoms, right? So there's the building blocks of the composite number x. Okay, so this case here, y and z cannot, because we need to make sure that y don't add up to 2 and 3. Okay, that's the thing. So basically, y here, y and z are terms like for prime numbers 5, 7, 11, 13, and so on. Okay, so these are prime numbers. So Mark claimed that x is a perfect square, while Henry claimed that x is a perfect cube. Determine who is correct. Provide the reasons to support answer. Now the thing is this: if it's a perfect square, all the power have to be divisible by 2. Okay, that's the idea of being perfect square. So obviously this is not divisible by 2. So we know that this is not a perfect square. Okay, and because this is already a prime factorized form given by this prime number, this is already a prime factorized form. So we know that there's no number here that will add up to this power here. Okay, so that's the main thing that you have to know. Then after which for x to be a perfect cube, same thing. All this power have to be divisible by 3, but we know that 2 here is not divisible by 3. Okay, so how do we write it? So I'm just write this like that. Okay, so I think that the thing is a perfect square has all even powers in its prime factorized form. So that is the main thing. And since y and z are both prime numbers, so the prime factorized of x can be expressed as this. This is the prime factorized form. Now, since not all powers are even, which is 3 is not even, 3 is not even, right? So x is not a perfect square. So that is the main thing. Then you write the same thing for the perfect cube. Okay, so because the power, as you can see, not all is divisible by 3, so x is not a perfect cube. So neither Mark nor Henry is correct. Okay, so that's how you conclude. That's how you do this question in proficiency.